Flack math! Give me some math and I'll give you some flack. Flack math!
All right, lesson 26. Now, remember your main goal is to get the variable by itself. So you're trying to find stuff that's hanging out with the variable on that side. You don't care about the other side. Okay? You want to get rid of stuff on the side of the variable. Get the variable by itself. Okay? But what happens when you have variables on both sides of the equation? Okay, this is still an equation. You could probably try to figure this out, what it is. What x will make this true? I don't know. Can you guys try to figure it out?
Don't you like move it onto the other side of the equal sign?
You will.
Like negative?
Yeah, that's what I would do. But I mean, I guess it's possible to try to figure it out right now by yourself. But it's going to be a fraction, so it's going to be more difficult, whatever. So here's the problem. When I say get the variable by itself, you're a little bit schizophrenic. Like, well, which variable am I going to get rid of by itself? Because there's variables on both sides. Well, here's the only time this is the correct answer. When you have a problem, when you don't want to deal with something, just get rid of it. Okay? That's not always good advice in life. Okay? But in this case, if you have variables on both sides, get rid of one. You can do that as long as you do the same thing to both sides. I'm telling you, you can do whatever you want to one side of an equation as long as you do the same thing to the other side. Okay? So we're going to get rid of the easier one to get rid of, which is usually the smaller one. So what's smaller, 3x or 5x? 3x. So I'm going to get rid of 3x. How do you get rid of 3x? Well, this is not being subtracted. What's being subtracted on this side? The 4. The 3x is not being subtracted. So what is it doing then? Well, the 3 is multiplying by the x. But what's the whole 3x doing on that side? It's kind of weird to think about. It's existing. Okay, so when in doubt, just subtract it. But here's why you subtract it. Because technically 3x is being added to negative 4, right? Because minus 4 is the same thing as plus negative 4, right? So see how 3x is being added to negative 4. Everybody see that? So how do you get rid of something that's being added? Subtract it. Okay, so but whatever you do to one side, you do to the other, right? So where am I going to put minus 3x on this side?
The other side.
Yeah, it's somewhere over here. I'm going to put it under this because I know that 5x plus 7 minus 3x, these two guys are going to combine eventually anyway. So I'm just kind of lining it up, kind of like what I would do is you line up place value when you add or subtract big numbers. That's what I'm doing here with the x's. So I'm just lining up, I'm subtracting it right there. You can put it wherever you want. It's just easier for me to see, oh, 5x minus 3x. What's 5x minus 3x?
3x.
What's 5x minus 3x?
1x.
You said 3x and 1x. It's 2x, right? 5x minus 3x is 2x. Okay, so this is still, we didn't change anything because we subtracted the same weight from both sides of the equation. So now we have the same kind of equation we had in the last lesson. We have to get rid of two things on this side. It's flopped, right? So now we have to get rid of everything on the right side instead of the left side because the variable's on the right side. Okay, so what do you want to get rid of first? 7. How do you get rid of 7? Subtract 7. And then now we have negative 4 minus 7. What's negative 4 minus 7?
Negative 11.
Negative 11, right? If it helps, you can chicken scratch. -4 plus -7 is -11. Now what? Divide by 2. So x equals -11/2. You can probably just stop right there, but I just like having it neat right there. Okay? So there's only one step that we added to this lesson, was if you have variables on both sides, get rid of the smaller one. You don't have to get rid of the smaller one. Look what happens if I don't. If I had the same equation, and maybe you're the type of person who likes to have their variables on the left. Okay? So I can still get rid of 5x. How do you get rid of 5x? How do you get rid of 5x? Right, because 5x is being added to 7, right? So minus 5x minus 5x. What's 3x minus 5x? -2x. And then -4, and you're just left with a 7 on this side. You guys following me so far? Okay, so now same process. We have to get rid of two things. What do you want to get rid of first? The 4. How do you get rid of the 4? Add, because it's being subtracted. So add 4 to both sides. -2x equals 11. Then divide by -2, right? And you still get the same answer. X equals -11/2. Now, neither way is right or neither way is wrong. Well, they're both right. But there's not a wrong way to do it. But why would I do it this way instead of this way? Any opinions on that? Yeah, if you avoid negatives as much as possible, then you don't have to be potentially confused or make a mistake, because a lot of times we make mistakes with our negatives. We forget the negative sign, or we forget to cancel, a negative divided by negative is a positive, or things like that. So if you can avoid negatives, try to avoid them. And the way you do that is if you have variables on both sides, get rid of the smaller one, because you'll end up with a positive 2x instead of a negative 2x. But it doesn't change the answer, it just makes this a little bit more confusing, dividing by a negative and things like that, okay? All right, so, yes.
Can I use the restroom?
Yes, you can use it. I don't know, can you? Okay, let's skip to example 3 here. 3x plus 2 minus x plus 4 equals -5 minus x minus 4. What happened? This does not look like the previous problem. So that's a lot of x's and a lot of normal numbers. What do we call these normal numbers? These are variable terms. What are these terms called? Do you remember? Starts with the C. Because they never change. They never change. They are constant. They're constants, okay? So there's multiple variables on the left side and multiple constants, and there's multiple constants on the right side and one variable. What would make our life easier right now? I mean, you don't have to do it this way. You could just start getting rid of x's and getting rid of all the smaller x's and things like that. What would make it easier? Yes?
Could you just add up the constant variable?
Yeah, so you can combine like terms. So you can add the constants together, then you can add the variables together. Can you do that in your head? What's a simpler way to say 3x plus 2 minus x plus 4?
4x plus 6.
Okay, not 4x though, because what's happening with this x?
4x.
Not -4x. So we have 3x minus x. So 3x minus x.
So 2 plus 6.
2x
2x plus 6.
plus 6. Okay? So that's, so far, right now, doing it in your head could be confusing. So here's what I would suggest. When you are simplifying by combining like terms, chicken scratch. So this, now, Zan would not have said 4x by looking at that, right? Because 3x and a negative x will come down to a 2x. Okay? So 2x plus 6. What about over here? Can you do that in your head, or do we need to chicken scratch? Chicken scratch. Boom, 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 boom. Okay? So what x's are we left with? Does the x change at all? Nope, because there's no other x's on the right side. We haven't started going multiple sides yet. We're just cleaning up each side separately. So that's negative x, and then what are the constants combined to?
Negative, positive, no.
Negative 9. So I'm going to say plus negative 9, because a negative plus a negative stays negative, but a negative times a negative turns positive. But a negative 5 and a negative 4 on the battlefield will combine forces. All right. So now we've got the same kind of equation we have above it. We have variables on both sides. Which variable term do you want to get rid of? It doesn't matter, but what's the easier one to get rid of? What? What'd you say?
Smaller.
Smaller one. What's smaller, 2x or negative 1x? Negative x. Well, negatives are always smaller than positives, but even if you ignored the negatives, the 1 would still be smaller. But so how do you get rid of a negative x? You add what?
1x.
A positive x. Yeah, 1x. Okay? So if you add a 1x to the right side, you have to add a 1x to the other side. I'm going to put it right under this because I know that I'm going to have to combine those terms, right? So that cancels nicely. I'm left with 3x plus 6, right? Equals a negative 9. We're getting closer. Now what? Subtract 6. So 3x equals negative 15, right? Because negative 9 minus 6 is negative, down to negative 15. Divide by 3, x equals negative 5. All right, and here's something, if you're taking a test, then you should do this. Plug it in. What's 3 times negative 5?
15.
Negative 15 plus 2 comes down to negative 13 plus negative 5. So that's negative 13 plus positive 5 is negative 8 plus 4 is negative 4. All right, plug it in over here. Negative 5 plus negative 5 cancels, and you're left with negative 4. Okay, we ended up with negative 4 on both sides. So you can plug it in and check it. This is kind of a complicated thing to plug it into, but I think it's worth it if you're taking a test and you want it to be right. Okay, so this leads us to this section right here, which is going to stay on here the whole year. These are the 4 steps to solve any equation in this book. Okay? Until we start getting into quadratic equations and things like that. But you can solve any equation with one variable and no exponents, but using these 4 steps. So I'm going to leave them up there, but I'm going to write them on the board just so our online learners can see it too. Okay? So here's the steps to solving equations. Okay? First step, simplify both sides separately. Simplify both sides separately. This is what Cheyenne suggested that we do to make it a little bit easier on ourselves. 3x plus 2 minus x plus 4. It's kind of like going into Starbucks and saying 3 Americanos plus 2 Frappuccinos minus an Americano plus 4 Frappuccinos. Starbucks person is going to say, dude, just figure it out before you come in here. Tell me how many Americanos you want and how many Frappuccinos you want, okay? Okay, 2 Americanos, 6 Frappuccinos. Okay, so simplify both sides separately. The first part of that we're going to talk about later. That's remove parentheses. There's no parentheses there, but we are going to talk about removing parentheses, and the way we do that is we distribute. But there's nothing to distribute. This will be in our next lesson. But the second part of simplifying both sides separately is combine like terms. So obviously there's like terms on both sides of the equation. Like this negative x and this 3x are like terms, but that's not what we're talking about. You can't combine those together. They're on opposite sides of the equation. But you can combine like terms that are on the same side together. Make it easier. Now we could have gotten rid of one constant at a time and one variable at a time to get it down to what we needed. But it's easier just to simplify first. Simplify both sides separately first. That's step 1. Step 2, the blue step, is a conditional step. The condition is if you have variables on both sides, then get rid of the smaller one. Okay, so if, underline if, you have variables on both sides, eliminate smaller one. It doesn't have to be the smaller one, but if you're going to write something down, write the smaller one. Okay, and to get rid of a complete term, you're either going to add or you're going to subtract. You're not going to divide to get rid of a variable term, or you're not going to multiply. You're going to add or subtract. So write that in parentheses, add or subtract. And that's what we did here. We noticed that, okay, I've got a 2x over here and a negative x over here. So I'm going to get rid of the smaller one. I'm going to add x to both sides. Okay? Step 3, the green step. If you have a constant on the variable side, which most of the time you do, we're going to eliminate constant from variable side. The constant term is always added or subtracted. So to get rid of it, you're going to subtract or add it, right? Now, make sure you say from the variable side. It's not always going to be the left side or the right side. Like over here, we have to get rid of the 7, not the negative 4. We're used to getting rid of stuff on the left side, right? But in this problem, we got rid of stuff on the right side. So this is an add or subtract problem as well. Then the last step, you'll always end up here. Eliminate variable's coefficient. Remember, the coefficient is what the variable is being multiplied by. So you're going to always divide. Okay, those are the 4 steps to solve equations. You're going to refer to that a lot. So if you want to write it on the front of your folder or even the front of your book, on your book cover, then you could do that. But this is, if you follow these steps, you can solve any equation in this book with one variable, or 1 degree equation is what we call it. But, so let's just do 1, maybe 2 more examples, and then we'll call it good, okay? All right, here is example 4. All right, k plus 3 minus 4k plus 7 equals 2k minus 5. We can do this one together, and then I'm going to give you 2 more that you guys can do on your own, okay? So without looking up here, or you can look up here if you want, what's the first thing we should do?
Simplify those.
Yeah, clean it up. There's an easier way to say the left side, and there's an easier way to say the right side. Can you do that in your head? Well, there's not an easier way to say the right side, sorry. The right side's already cleaned up. There's no like terms on the right side. There's no other k's, there's no other constants. Okay, so what's an easier way to say the left side? Can you do it in your head? Nathan?
Negative 3k plus 10.
That's it. Okay, so this is subtraction. We're combining like terms, so chicken scratch the subtraction. 1k, because remember a k by itself is just 1k, plus negative 4k is negative 3k, and then 3 plus 7 is 10. That wasn't terrible, right? Okay, now, what's the next thing? What's the blue step? What do we do next? Eliminate the smaller what? Variable term. So which one's the smaller variable term?
Wait, negative 3k.
Right, because the negatives are always smaller than positives. Okay? You can get rid of the 2, but we would subtract it and we'd end up with a negative 5k over here, right? There's nothing wrong with that. Just more negatives mean more confusion. So how do you get rid of negative 3k? You add positive 3k. I mean, technically, the negative 3k is being added, so to get rid of it, you subtract a negative. Well, subtracting a negative is what? Adding a positive. So you would add positive 3k to both sides. Okay? And then I'm left with 10 equals, what's 2k and 3k? 5k. Okay, so a lot of you said get rid of the 2. Do you see why? You could have gotten rid of the 2k by subtracting it, but you would have had a negative 3k minus 2k. You would have had a negative 5k plus 10 equals negative 5. Nothing wrong with that, but there's a lot of negative in there. So potential confusion, all right? It's not wrong, it's just you're living life on the wild side, okay? If you're okay with that, then go for it. All right, what do we do next? Yep, the green step is get rid of the constant term on the variable side. What number is the constant term on the variable side? 5, right? And what's the 5 doing? What's happening with the 5? It's being subtracted, so how do you get rid of it? Add 5 to both sides. So 5k on the right side, 15 on this side. Well, this is going to be a pretty answer. Now, how do you get rid of that 5 in front of the k? Divide it. So k equals a nice, pretty 3. I'm just going to plug it in here. 2 times 3 is 6. Minus 5 is 1. Okay? Well, let's plug it in here. I got 3 plus 3 is 6 plus negative 12. What's 6 plus negative 12?
Negative 6.
Negative 6 plus a positive 7 gives you a positive 1. They both equal positive 1 when you plug in 3. Awesome. All right. 2 more and then I'll leave you alone. So see if you can do this one by yourself. You can compare your answer with somebody next to you. Okay, go for it. You guys can Do it and then compare with someone next to you. If you get close to somebody, make sure you mask up. If you get close to somebody. Oh, do you have to do the problem? Technically, you don't have to go the speed limit. But you're one of those people on the road that everybody hates.
Answer the question, please. Please, just answer it.
You don't have to do anything.
It's impossible to do nothing.
That's right.
I'm not gonna look at friends at home. We're gonna go like, dang, that kid is so weird.
So, Eliana, do you watch my videos?
I do.
Okay. Is this, when we do this stuff, are you just like really bored? Should I put music in there or anything? Like when I'm asking people to work on their problems, are you actually working on your problems at home? But like, would it help to put like elevator music or something?
It would be distracting.
Okay. All right. It's good to know. Thank you. I mean, we have this music over here, so
That's true.
you can usually hear that.
The first time I just saw something, I stared back. This is the sketchiest thing.
Okay, when you're done, you can compare with someone. Don't compare with Ethan. He is one of those guys. Just shake your head when they pass you on the road. Going 66 and a 65. It is these days. Did you do it in your head?
Nope.
You just didn't do it. You're one of those guys too.
No, I did it.
Okay. All right, I'm gonna start. You keep working. I'm gonna start working at it on my own. And we'll see if we get the same answer, okay? All right, how'd you guys do? Did you guys get that?
Mm-hmm. No.
No?
So I did it wrong. I see where I went. Did it
Okay,
wrong.
so show your work. It's gonna help you more than it helps anybody else. So look at your work and see if you got the same steps here. To get negative 5n plus 3 equals 5n minus 5. Okay. And you have a question, Nathan?
I just did 75.
Okay.
I just got 1 because I took, on the right side, I took the n, and I subtracted it from 4n.
Yeah, because it looks like that, but really the 5 is being subtracted, but the n is being added. So remember, it's not what's to the right of the term, it's what's to the left of the term. So 4n is not subtracting anything. 4n is actually being added to the whole right side. Okay? 5 is the only thing being subtracted. Okay? It's not being subtracted from 4n. Well, it's being subtracted from the whole side. Okay? So you kind of have to ignore whatever's to the right of terms, because that'll confuse you. All right? Good. And then getting rid of the negative 5n by adding 5n. Boom. Get rid of the constant by adding it because it's being subtracted. And then you're here and you're like, uh-oh, did I do something wrong because this looks fractiony? But no, fractiony is okay in this problem. All right, do you guys need another example? Ethan, you want another example? Ethan says no. So I think we'll call it. You can do another example if you want in the book. Example, there's one more example, example 6. You're welcome to do that if you need more practice, but that's it.